Hey everybody, welcome to the segment introduction for the completed or nearly completed workhead base. The rest, this video will be probably 25 or 30 minutes, and it covers just the machining operations after I had bored and turned the spigot and put the lock in there, the split cotter. Just the machining here, machining of the shoulder, machining of what I'm calling the degree arch, and then the stamping of the degrees. As a little teaser, let me show that to you. I don't know how good it shows up in the camera, but I'm really pleased with how that came out. I haven't done any finishing on this. I just simply ran a file across it to get the burrs off. The lettering's not quite, the stamping's not quite perfect, but definitely serviceable and nothing to be ashamed of. So I'm real pleased with how this came out, and I'll keep this introduction relatively short because there's a lot of machining steps that I want to show you. You'll notice that there's a little shoulder that's machined in here, and the purpose of that is that this is actually, I've decided to make the alternative design, which I'm actually glad I got the prints from Gary Martin at Martin Model and Pattern, because I didn't realize this at first, even though I've been studying this project for a long time. But there was an alternative design that came out in 1986 that has to do with the tilting bracket, and I'll get into that when I actually fabricate this thing. But apparently there was a tendency when you tighten this down, and again, the tilting bracket fits here on the workhead base. Apparently the original design, which just had a 5/16" bolt through here and a ball handle to tighten it down, apparently it had a tendency to move, and so they came up with a cone-shaped different bolt design that, like I said, I'll show you that later. But part of that bolt, it incorporates a shoulder on here, so that's why I machined this step in. It's a 3/32 inch step underneath the boss here. So I'll describe that later, and that is not covered in the Quorn book at all. So again, I'm glad I got the plans, the prints from Gary Martin, and we'll go over that when I get into the tilting bracket design. I was able to find that edition of Model Engineer magazine where they discuss that change, and put it on. I've ordered it off of eBay for about $10, so I'm pretty pleased that I was able to get that. I don't know if that'll add anything to the prints that are already here, but it might. And also want a debt of gratitude to a gentleman named Dan, who is on the Quorn group, that his handle is Love to Fish. So Dan sent me a bunch of photographs of his Quorn in the building process. So here I am. Gotten, the wheel head is all complete basically. This arm is done. Now the workhead base, which will go right here, is finished. The only thing I haven't done is to cut off the back. I thought I'd wait till I get the article and to see if there's anything that's special that I need to do with the back here. I don't think there is. I think I just lopped this off at a 1/2 inch, but we'll see. So I didn't drill the hole all the way through. I drilled and reamed the 5/16 down about 1 inch. So whenever I cut it off, as long as I cut it off shorter than 1 inch, it will be there, it'll be fine. So the next thing I'm going to work on is machining the rocking lever and I'll have to put in a split cotter in that as well. So I'll cover that in the next video. But stay with us for the next 25 minutes or 30 minutes, if you will, and you get to see how I've finished fabricating this. Thanks again, everybody. I look forward to keeping you updated on the project. One more thing, and welcome again to all the new subscribers, and thanks for your comments and encouragement. Those of you that have made a comment on the YouTube channel, I appreciate that. It's very nice of you to do that, and I hope to gain some more subscribers. And again, hopefully, I'm just an amateur building this project, and hopefully my experiences will help somebody else who wants to build their own Quorn. So thanks much, everybody. I appreciate you, and enjoy the rest of the video. And for part 2, we're over here at the mill. First thing I did was let me zoom in. I used a couple of micrometers to, or dial calipers really, just to mark the center, the rough center, the approximate center I should say, of this little cast iron button here. And I used a center punch first to mark it so that I could put a scribe into it. And right here I've got these trammel points. These are some nice, I believe they're Starrett brand trammel points, but I use them for setting the timing, or actually when Fred set the timing on my locomotive. But I've set these at 2 inches apart, and as you can see I put some bluing on, Sharpie marker on the castings. Just, I wanted to see from the center, just scribe a little line here so I could get an idea about how much material needs to get removed to make a 2-inch arc. So it's not very much. That's all the point there. Just doing the layout in advance so I could visualize some of the work. And I've got the rotary table on the mill. I've got to finish zeroing it out exactly, and then it'll take some time to get this set up just right, because I'm going to be milling this surface at a certain distance, a certain height above the center line of the bar here. So I want this to be level as possible, and basically both these surfaces to be fairly level when I clamp them down on the top of the rotary table. So I'll bring you back when that's done. Here I'm checking the alignment of the rotary table with the coaxial indicator, and as you can see the needle is moving just a teeny bit. Each of those divisions is a half a thou, so it's just bumping. It's almost like it's hitting a little piece of dust or something inside the bore there. So I'm very confident that we have the rotary table sensor. Very happy about that. And when I do, then I'll zero out everything on the VRO, so I can, when I back it off the 2-inch radius, I'll move the table over for that. Okay, I've spent a little bit of time setting things up on the rotary table. As you could see last segment, I had zeroed in the rotary table on the table, and now I've placed the object on the bar on matching V-blocks, and the first thing I did was to tighten the unit up, the workhead base, to the column here. And so it's tight, it's not going to go anywhere, and it's important to do that if you're going to do this method, I think, because there's a limited opportunity of other things to clamp. So I've got clamps on the bottom of the V-blocks here, and I've got big clamps on top with some brass to protect the bar. This is the rear bar, so nothing's going to be sliding on it going forward, but still didn't want to ding them up, because I've put a lot of tension on these nuts here. So there's a piece of brass underneath that one over there as well, and I used a pointer. This is something I had turned a long time ago. I had marked the center of the burr, if you will, and I used this center thing to hold it down. I locked it down while I've got it. And one more thing I'm going to do is to align the bar perfectly with the y-axis, as good as I can get. It's going to be interesting to see how good I can do that, but that'll be important because I want to set the 0 here for the eventual marking of the degrees. So I'll bring you back for another segment when we get a little further along. Okay, one more thing to show with the setup. I've used my little Starrett back plunger gauge that I usually use for aligning my vise along the x-axis. As you can see, I'm using it to align the bar along the y-axis, so that whenever I do the degreeing, that I'll have a place that I can mark as my 0. So I thought that would be handy to do before I get started. So one more thing, I guess I'll tackle the machining tomorrow. Alright, now we've got the shoulder machined. I've got the mill in position, and I'm set up to take my initial cut off of the degree arch. I've unlocked the rotary table, and I should be able to just move this thing through its arc. We'll see. It'll be very interesting to see how this works. And this is basically the same motion that I'll be using, except the inside of the cutter, I'm going to clean up the inside. like I said, I'm taking off only about 15 thou here. Looks like I'm getting a pretty nice cut. I think I have to take off about 30 thou. I got to go down to 1.125. So I plan on just repeating this. This is kind of cool, kind of fun. Just bring that thing back and unlock the Z. And 149 there now. A few thou more. A bit more than I wanted. Shouldn't be too many cuts here. Sorry about blinding you there. Very nice even feed. Back off this too again. Feeding it manually like this, you just get a good feel for the cutter. Since I have the end mill zeroed at 1.125, or excuse me, at the center of the bar, we know we're going for 1.125 here. Is how far this arch should be protruding from the center of the bar. Alright, I'm going to cut the video off now and get the idea. Okay folks, I'm getting ready to machine the inside of the degree arch. As you can see, I got a very nice finish on the degree arch. Didn't take off much, 30 or 40 thou. And what I've done, I locked the Y. I just want to kind of talk this through first. I'll try not to belabor the point. But I locked the Y at 0. So my center point is my center point. Now, I know I'm going to take off a little bit. I'm 1.125, the Z-axis there. That's the top part here. Sorry for yanking the camera around, but I'm trying to help people that might want to machine this project. So next thing I'm going to do, let's say we'll take off 25 thou. So I'm going to move that to 1.10 on the Z. Alright, lock it. It's almost one, just a shade more than that. Okay, so I'm taking off about 25 thou. And I'm not going to be able to really machine and crank that thing at the same time. But let me get started anyway. Turn the rotary table on. Turn the phase converter on. All right. Okay, so now I've got my depth of cut set. I've got my Y axis zeroed, and my X is beneath. It's not as far out as it needs to be. The final dimension will be 175 thou, or 1 inch 750 thou. So what I'm going to do, I don't know what the contact is yet. Let me turn this on. So we're shy. I don't know the right way to say this, but what I'm going to do is unlock the X and just move that so it just barely touches. That's why I'm not going to be able to film the whole process here. This is a two-handed thing. And I want to at least get you started with showing you what I'm doing. Alright, I can hear it making contact now. So now, again, I'm only taking off 25 thou, depth of cut, turning the arc. And if I understand the book correctly, they want me to take 250 thou, make a little ledge in there. I'm sorry about the camera work there, y'all. Okay, so I'm going to turn this a little bit further on the X. It's not a lot of material to remove, so So 1.662. Let's go about 20 thou more. Lock the X. I'm gonna kind of have to do this by feel. I think what I may do is leave this depth here and go all the way out to the 1 3/4 arc that I need. There we go. Yeah, it's looking pretty good there. Pretty uniform cut. So that's probably what I'll do. I'm at it. 1.68. It's only another 100 thou, less than 100 thou to go to bring the X-axis this way. So I'll move that. I'll make some repetitive cuts, and then I'll just adjust my depth of cut down to 25 thou. I'll bring you back when that's done. Okay, thought this would be worthy of a quick video. This should be the last cut that I make. I'm taking off about, once I got the 0 on the Y set and the 175 cut set, I've been taking off only about 25 thou or so depth of cut. So obviously I had to make a bunch of cuts. But not bad. Again, you know, with the setup and everything, I wanted it to be the cuts to be gentle. Let me brush off this cast iron dust. I'm just really pleased because I checked all the bolts before I started and checked everything is still nice and tight. Really pleased with the machining setup. And again, it seems like a lot of you are appreciative of me showing how I'm doing it. So if you have a mill and a rotary table that's capable of doing this, this looks like a really good way to do it. So there's my 1/4 inch cut, the edge of which should be a 2-inch radius from the center here, which that should agree with the line I scribed last night when I was just laying things out. And looks like I have a very nice, at least a 1/4 inch worth of material to put my lines in. So now I'll go back to the 0-0 setting, replace the end mill with the scriber tool, and get set up to start making my degree marks. Alright folks, really excited. Just finished scribing in the, I went ahead and did 35 degrees on either side of 0. Just to describe this briefly, I didn't want to try to risk scribing and videoing at the same time, but anyway, that hopefully you can get an idea how cleanly that came out. This is the same scribing tool that I've shown before. I used it, I built it for the George Thomas 3 3/4 inch rotary table, and it's works out great. I did use the little honing stone to hone it sharp, and I wanted to show this is just half of the degree marks that I did. You know, basically if you're going to go 35, you know, either side, so you're making 70 marks, but in order to line the thing up like I showed earlier before I did the milling, this was not set on 0. I would have loved to have had it set on 0, but my 0 was actually 344 degrees. It's a long story, but the way the markings are and the way the clamps and everything needed to be, that's what worked, which was another reason for me to write everything down. But then so I would write it down, and just to show you the procedure anyway, in case anybody's curious, I zeroed out my little scratching tool on the surface, and then what I would do is move this down to about 10 or 11 degrees on the quill. I would lock it, and then I would move it, and these numbers here correspond, like I just finished the back half of it, so that for 35 degrees on the left side I moved it 110 thou, and then the next marking 310 degrees, which would be 34 off the center. That's 75 thou scribe line, so I made 4 of those, then a 150, then 475. So the 5s basically are 110 thou and the 10s are 150. The reason I did that is I mic'd the surface here before I did the work, and this ridge, if you will, is about 300 thousandths wide. This dimension here, let me show you. Yeah, here. So I figured a 150 scribe line would take it halfway across. Still leave some room for me to stamp the numbers, which is the next thing to do. I just need to figure out how I want to do that. I may sleep on that. Obviously, I have the universal pillar tool, and it would be the perfect thing. I'd need to set up the tool, brace it somehow to the mill table, and use the stamper. So I'll play around with ideas, and I'll bring you back to that. And here we are after carefully checking all my measurements. I've drilled out the hole, and now I'm going to ream it with a 5/16 inch reamer. Just make sure it's nice and uniform. I'm only going down about an inch. The finished dimension of this part is 1/2 an inch. Make sure we got it good here. Alright, as you can see, I've got a shopping bag here with a magnet in it. That's what I use for when I'm machining iron. I put one on the lathe too, I forgot to mention it, but then you can just brush your pieces off and they stick to the magnet there. It makes cleanup a lot easier. Okay, here I am taking the last little bit off of the, get you close in here, the surface. This is basically the mounting surface on the top of the workhead base. I only had to remove about 150 thou. I took a tiny little bite, so I'm only taking off 15 thou at this time, but I set the end mill on top of the bar with a little shim there to protect it. And then I subtracted 1/2 inch, and I set my Z at 0, so that the bottom of the end mill was exactly the same height as the center of the bar, which is the plane that this surface is supposed to be machined down to. And like I said, because it's mounted on the rotary table, I've been taking very small cuts, very light feed, as you can see. I just wanted to give you a sense of what I'm doing here, because it's clamped down as securely as I possibly can get it on the rotary table, and the rotary table is locked with these lock arms here. But nonetheless, I mean, if you hit it wrong, if you hit it too hard, you could certainly vibrate it loose, and that would be a very bad thing. So good to take your time, be a little careful here, and cut it off. And that's the 0. That's as far as we're going to go on that, which I'm real happy about, because that leaves a little bit of a protrusion here, as you can see. And now the next step is to machine down the top part of it down parallel with the bottom of the bolt down to 3/32. So I think what I'm going to do is come out here, just so, because that's sort of an eyeball operation. I'm going to take a little break. I'm going to blue that area up and put a scribe across the line there, across the bottom of the hole. And I'll bring you back when I've machined that down. There I've got the line scribed. So I'm going to use the same technique. I'll be taking off just about probably 15 thou or so at a time, 16 thou. Make repetitive cuts back and forth along the y-axis to bring me down, reduce that, make a 3/32 of an inch shoulder, so I can use the alternative bolting method for the tilting bracket. Alright, here we are making the final cut. The last 15 or 16 thousandths of an inch. Cutting down, making the shoulder for the alternative mounting bolt. And go straight back. With the camera work, I'm trying to watch what I'm doing at the same time here. What I've been doing is locking the x-axis. Feeling there. Yeah, it feels good. Nice and smooth. Guess I should have cut that off first. Yeah. You can't even fill those little machining lines. So I got a 3/32 inch notch machined there. That'll be a perfect shoulder for the bolt. And now it's time to move on, get set up to machine the what I'm calling the degree arch. The book doesn't really call it a certain name, but I'm calling it the degree arch. Okay, now the machining is done, the degreeing is done. It's time to stamp the numbers. And I really wanted to use my pillar tool that I made, so I came up with what I hope is going to be a clever solution for mounting it, because it's tricky to. I'm doubly glad I got the long arm one, because as you can see, this thing is just barely long enough. What I've removed the post for the pillar, and I've got, because it has this 3/4 inch base, I've got it in a 5C collet chuck for 3/4 inch and in a square block and in my mill vise, and as I've got it bridging the gap a little bit, and I've got the 0 one in there right now. So I'm gonna try stamping this, and this way what's nice about this arrangement, if this comes out okay, then what I'll be able to do is crank the handle over, move it over 10 degrees and then stamp the 10. I'll still have to kind of manually work the spacing out between the 1 and the 0, but the 10 and the 20 degree marks, and then keep cranking it all the way around to do it for the other side too. So that's my plan. Let me show you one more time how nicely those degree marks came out. I haven't done a thing, I haven't stoned it or anything to remove the burrs. You can't really see it very good from there, but let me get a flashlight on it. Really pleased by the degree marks. That's one of the trickier things to do with a project like this. There we go. Look how nice those things came out. So, I mean, even without the numbers, I'd still be able to tell very accurately what degree of tilt that I had on the machine. I'm really, really pleased how well that came out. So I'll bring you back once I have the numbers stamped in.